afternoon, everybody. Welcome back to the chatter room. In a moment, we'll be starting the presentation by Michael Nahr, Data Science in Wind Power Production. Michael works for TransAlta. He's the Supervisor of Operations Analytics in the Data and Innovation team. And without further ado, actually with a little bit of ado, chat amongst yourselves, please, in the chat box on the right-hand side there. And please put your questions in the Q&A area. I'll just clear out the questions from the last session. There we go. Our very kind volunteer, Rita, will keep an eye on the Q&A and interject, she'll run the Q&A questions at the end. How do you want to do this, Michael, with the questions at the end, or?
Yeah, we can do them at the end, unless there's something that Rita wants to interject and just pop in, and I'm okay stopping wherever I am.
Fantastic. Well, thanks so much for joining us, and over to you. Cheers.
All right. So, as someone with a natural curiosity for details, I've always enjoyed working with data, as it's like a puzzle. You have all these pieces, and as you try and sort through them and stitch them together just so you'll hopefully have something at the end to construct and show for it. That's really what led me down the path of data analytics, away from my core field of study. But this was even before I've heard of data science. And then now that you fast forward in time, everyone under the sun has heard about it. They see the attention-grabbing headlines. AlphaGo beats top Go player. Data is the new oil, and so on and so forth. And the next thing I know, I am evaluating a vendor and their product where their AI is telling me that to make a wind turbine hotter to get more power out of it. Correlation does not equal causation. For your information, heat is a byproduct of electricity generation. It is not the other way around. So yeah, in the interest of time, my story is concise, but I really do believe that people have come to a somewhat better understanding of data science over the past few years. It can be messy and tedious to collect and clean. It's not always the most sexy thing to do. You're sometimes missing key information, and getting results sometimes takes longer than you thought, but there's so much untapped potential in data to make things better. And in this case, with the audience we have here, I know I'm preaching to the choir, but I'm really here just to show our journey at TransAlta, where we've combined subject matter expertise with data, technology, and empathy to deliver innovative solutions that solve real problems in our process-driven industry. My name is Michael Nahr. I've worked in a number of roles at TransAlta in our power plants before taking a position in our wind group as a performance engineer. My role there was primarily about trying to get more energy out of an existing asset. So I say asset, a wind turbine in this case. That's not all I did. Anything that needed a piece of data, I touched. So you can imagine lots of things in a business need data, contracts, addressing reliability issues, reporting, and I've learned enough about control systems to know that there is a lot more to learn. And today, I'm the supervisor of our operations analytics group in our data and innovation team. And I'll talk a bit more about our team in a bit. So yeah, our agenda today is talking about what's a business problem, what was our journey like as we try to solve that, what's left to do, and where do we go from here? If you haven't heard of TransAlta before, because there are many Alta companies, we are an electricity generation company. We are Canada's largest producer of wind energy. And over here, you can see our fuel mix will be off coal by the end of this year. And our leader in clean energy. Okay, the next slide here. We operate in Canada, US, and Australia. This is just a map of our operations for anyone that's curious. Yeah, so just want to talk a bit about our team. Who are we? Who is the data and innovation team? We started as a handful of individuals pulled together from different areas of the business with experience in operations. So when I say operations, that is related to our generating assets. So coal plants, wind farms, solar, hydro, etc. Finance, people come from finance, people come from trading. No one's from IT. But we are all doing our quote unquote day jobs while innovating in our silos. There are limitations to that. You can only move so fast while also trying to complete core business functions. So yeah, now with the formation of this group, they put all these people together and said, okay, here, come together and innovate. You know, I describe us as a scrappy startup. That's where, you know, we have the opportunity to try lots of different things, but at the same time, the pressure is always on to deliver that value back to the business. And so, you know, when I use the word innovate, you know, I realize innovate is a buzzword in a sense, but it's definitely in our team title, and I'm trying not to use it too often here. So if we talk about more specifically what we do, we're about empowering TransAlta to reinvent the way we work. And these are kind of our core functions. We have analytics, where we interpret data, automation. Automation refers to robotic process automation, business management, BPMS, business process management systems, for anyone that's familiar, and as well as developing custom applications. And we service businesses such as the operations group, trading optimization, and really we do process improvements across the business. TransAlta, if you notice on like the previous slide, is a 100-year-old company. And now you start a team of around 10 to try and disrupt the status quo. In my mind, that's frankly a recipe for failure. But I think the leadership team knew there needed to be a change, and it had to be driven from the business. So by having us come in, we bring with us the expertise and the relationships to drive change. You know, software is easy to change, people are not. So we whether it's in some ways in that initial change, there is some baggage associated by leaving our existing roles. At the same time, it is those relationships that allow us to drive change throughout the organization. Yeah, our team's just about making big bets. You know, how do we drive change and do the things that need to be done and reinvent the way we do things? Start over again if you were to have a power company today, and you just not be afraid to take risks. You know, we don't let the idea of failure stop us. We've grown over that time as a result of us going and challenging that status quo. So we're gonna rewind time here a bit, 4 years. We're gonna start with a basic question. How much power could my wind turbine be generating? On the left-hand side here, we have a power curve that, you know, for our wind turbine basics here, where you see the scatter plot around the curve itself, that's just the output of the turbine. So for a given wind speed, you would be expecting a certain power output. Traditionally, we have solutions that have been built. We calculate means, we were using 10-minute data, a lot of the stuff was running automatically, and it worked fine. Like, it did what it needed to do, it accomplished the goal, whether we were trying to determine lost revenue, or we were troubleshooting any problems. But as we started to get more nuance into complex challenges, that just wasn't good enough anymore. You know, knowing what your power output should be is simply one building block in the grander scheme of certain things that you're trying to do. So with our existing system, we didn't have the fidelity to see maybe the way a turbine was turning. Like, we have a historian that was capturing all our high resolution 5-second data, but coming back to, like, how do you manage all that? And that's where some of the challenges come from. And with our existing systems, they weren't set up to do that. And as well, because of the way we developed our models and our data calculations, it didn't account for seasonality. We would go in and have to manually update it every season. And you have to remember to do that. Sometimes you get busy and you forget. So there's different reasons why that was a good enough solution at the time. But now we know we need to do better. So this is a challenge that does not start off as a data science solution finding a problem. It's a problem looking for a solution, right? We're not out here saying, okay, well, let's just pull this thing off the shelf and, okay, now how can we apply this and bring value into the business? What do we need to solve problems? And at the end of the day, it's really around empathy, domain expertise, and the appetite to take risks and craft a story that translates to value with a bottom line to sell it. On the right-hand side here, I have just the data science process as like a map highlighted here. I'm not in any way going to be spending a lot of time in that. I mean, people here would be familiar with it, and then especially with all the previous talks. Oh, I see the chat. Oh, I don't have any computer fans. It might just be my headset. I can always swap headsets here if it becomes really bad. Yeah, where was I? Oh yeah, so I'm not going to be diving too much into the data science process here, especially because other people would have covered it previously, and some of the other talks that have been going on the past couple days. But really what today's talk is around the journey and the stages at which we continue repeating this data science process. I do have a Lego wind turbine somewhere, but it's not here. So yeah, this is just the starting point. And I'm just gonna change slides here. Yeah, so our journey, I mentioned talking around, you need more accurate power predictions in this case. So what was our previous state and what was our next state? Previously, I was doing all my work in Excel and with SQL databases. Coming back to, that was a good enough solution. And in this case, where we have this 10-minute data, like I mentioned before, we're losing the fidelity with the limitations of our setup. Now, okay, well, can we try and shoehorn in what we're trying to solve within these tool sets? And this is where we were really struggling, because Excel has row limits, and you're not going to be able to fit all the data in. SQL is not exactly the best place to be calculating and computing large amounts of data in pivot tables. So this is where we were brushing up on the limits of Excel and SQL. Over the other areas in the company, we're starting to talk more to each other and make that connection and try and work through those problems, where they were definitely ahead of myself in terms of some of the different technology we were using. So this is where I'm coming, people are introducing, oh, hey, here's Jupyter notebooks, and here, you should be using Python to solve these types of problems. Okay, great, learning those skills, and we were able to quickly adapt and make those changes to actually solve the things we need to do. We were utilizing open source tools to achieve those outcomes. No, I did not know all the things we needed to do to develop a machine learning model at the start of it. But there's documentation out there, you're able to read it, and try things out. If it doesn't work, you can tweak a setting and then keep going. So that's one of the, I think, the great accessibility of data science with the amount of information that's out there. That's really great quality, and then you can try that stuff. So in this case, I'm definitely glossing over some of the data extracting and some of the other things. What we're talking about here is like all these things are kind of going on in parallel together. It's not necessarily sequential, but I think in this case, when we're just discussing the actual computing the model, we got to the point where, hey, yes, we got a machine learning model that's running on my computer, that's predicting a power output, 96, 98% accuracy. Now we can use that and build on it to do other things. Okay, now we can feed it different types of data and say, okay, well, we can maybe need to do this type of maintenance activity. But now we have all these other questions that are creeping up. So you have this model. How do you maintain that? And I built the models for one site. How do you do that another 700, 800 more times without going crazy or waiting years for all that to happen? And how do you make all this stuff accessible to other users and the broader company and make that discoverable? So this is really, there's lots of things happening at the same time that's serving as a catalyst to this journey and really kicking us off and building out our modern data architecture that makes the best use of cloud computing and storage. And really, is that, like we just talked about, the first thing is to even get that data. I have here, I've just drawn kind of a box on the left-hand side there, just a whole bunch of data sources. I have Microsoft's standard reference architecture there on the right. I'm not going to do a full diagram showing a before and after state. That'd be way too much effort. But in this case, we're just trying to talk about centralizing the data and building at scale. Coming back to the idea of, well, you have to build 800 turbine models. That's one model. Now, what if you have to do a second model and a third one? And how do you maintain that? So this is really where a lot of challenges come from. You know, when I said we need higher resolution data, our historian saves 5-second data, and they've been saving it since the sites have been built. So we have a lot of data. One turbine, I mean, if we want, be about 70 million records, I think it's about a year for a site. Because you have like one turbine, 1 minute data, so you have, 60 records in an hour, 24 hours a year, 365 days times 133 turbines. That's a lot of data that you need to be pulling that is extremely painful with the existing system we had, because they're just not, it was never originally designed to do that. So when I'm talking about the before state and when we were trying to build those machine learning models, I think, okay, go to our historian, what did we first try to do? There's a way you can query the data out using Aspen SQL, but then that's a single-threaded operation, so it's very slow. That in itself has its own row limit, and then you have to like copy and paste the data. It's not a really good way to save it. So that's not sustainable. That's very difficult to try to get through and build things with it. One of my colleagues at the time built a multi-threaded data puller. So, finally. So, it's going through our ODBC connection. It's just a communication protocol. And we're able to simultaneously pull large swaths of data at the same time and save them into a bunch of CSVs. And that's definitely why I have a lot of CSVs in my little graphic here, because we were doing stuff using just CSVs. At least you're able to get the data out and into a place where we could use it. And let's even set aside machine learning for a moment. If you're just trying to do other descriptive analytics, just trying to get that data out was such a challenge. So this is like, in and of itself, that threaded data puller was like, oh, a godsend. But then, once again, that only takes us so far, and we're still running things off of our computer. And now this is where our data and innovation teams getting formed. And like I said, all of these things are basically happening in parallel. So it's kind of a bit hard to distinguish when our team was actually getting formed relative to some of the work that I was doing by myself before. But we have our team being formed. So now we're forming the data lake and we're going to start populating it. Great. Now we're shoving a whole bunch of data in there in a controlled manner. We're trying not to make it into a data swamp where anything that we're putting in there has to have a specific use and is, with documentation, we have data stewards, we have enough information about it that we can come back and govern it. It's really the idea. And from there, we're able to use Databricks and build lots of existing or new solutions, I should say, at scale. So now we're computing lots and lots of data and without having to babysit it on our local machines. And then I'll just call out, so now like we're talking about today, so we have data landing in the data lake, but we don't have this way to get real-time data effectively to our models or to the different places that we need it. So now we've strung together a fourth solution where we're pseudo streaming data through a separate SQL database. But in this case, it works and it helps us serve what we needed to be doing. And we're able to get data to our customers and where it needs to go. Okay, so I mentioned we can be building 800 models or 1,600 models, and you got tons of notebooks, whether they're actually, you're just building different analytics or business intelligence. How do you manage that? Our previous state, you kind of hope nobody needs it, and you kind of save it on a network drive somewhere, because everyone's working in silos. I know I am guilty of naming things like this, V2, and if V2 is someone else's, I'll append my initials to the end. So that was our idea of code management. We'd save the files and put them on the network drive, and when it comes time to pulling it off the shelf, we just gotta know what it is or what it does. And same thing with our models. They just sit locally on our computers, and we need to run them if we needed any sort of information. And at least the stuff that was running off the database was backed up by IT as well. So we could also roll back some of those things. That was our closest idea to any sort of version control that we had. Now, fast forward to today and kind of our current state, we are saving our code inside of Azure DevOps. It's not everything is in there. It's definitely a learning, or I should say an iterative approach. So as we have different things we're working on or something that we're revisiting, we're trying to ensure that goes into DevOps and we have some sort of source control around it. And some of the things that we're working on now, the colleague on my team, ensuring all our models can go into Azure ML and we can start tracking the score. And so a lot of those things are really important. As if you start to change a model, or if things start to, depending on you want to change certain features, or if other things are changing, you're able to see how that performance is. And you probably can't read it here on the slide, but you can track things like your R-square and your RMSE. Another really nice thing around Azure ML is the ability to create API endpoints out of your models for consumption into other tools. Which brings us into kind of the next kind of another area is, what's the point of building things if it's not going to be used anywhere, or if it's just sits on your local machine? I half joke on this previous state where stuff just exists in a black hole. You build things and nobody else knows about it, or a few people know about it. And in that case, how are you able to craft a story to actually find and innovate and deliver a new business value? So we can't lose sight of our customers' needs and what we're trying to accomplish at the end of the day. If you can't communicate it, no one is going to care what it is your model does or what it is your analytics do, especially if it's not tangible. And then there's definitely a misunderstanding with the amount of effort that comes into actually producing that result. And here we've definitely tried many different things over the years to get data and information and results out to our different customers in the wind fleet. You know, initially we did stuff, and this is again kind of pre the formation of our team. We did things using Excel as our front end. That, you know, it would do a query. You know, you click a button, you do a query, and display a result. It may or may not be delayed, and that worked. It wasn't great. It didn't really provide real-time value, but for some of its use cases, it was fine. Next iteration, we built stuff on our historian where we could have that real-time data, but then the historian isn't designed to compute certain things in a certain way. So now you're shoehorning things to work. So for example, for the power curve, you're trying to do a power prediction, you're fitting different equations to try and determine what that output should be. And in that case, it's not necessarily accurate, but again, close enough. Like close enough sometimes is good enough. You don't need to be perfect with everything. The next iteration we're talking about, it would be shoving things through Power BI, and we did all sorts of very interesting things to make that work. I'm not going to go into those details, but needless to say, it did work. We definitely did not want that to be a long-term solution. We did some hacky web-based stuff, kind of prove out the concept. And today, it's just, that's what I have there on the right hand side is just a little screen clip of from our web application we've developed in-house for our operators that they use today. And this is built by actual software developers, people who know what they're doing, as opposed to those of us who are not and just wrote code to make things happen. We want to deliver something to the customer that they can use. In this case, this is come back to that pseudo real-time thing I mentioned earlier about us developing. That is helping feed data into our application. And here, the graph, again, may be hard to see, but that's okay. You just need to kind of look at the colors. We have gray, some gray lines, that's our actual power output, or you see some green lines, that's our expected. And in this case, we're not actually using our machine learning model in this instance. Just coming back to, we're trying to get some other infrastructure set up. So here is an between our previous solution and our machine learning model to get it to work in the app. But we're ready to take it out and plug in our API endpoints and get even better results. And then in the red there is some icing prediction stuff that I'll mention later. But here's the idea of the operators had this problem where they can't get information real time about their site to be able to make effective decisions outside of what the SCADA system, the control system, was already telling them. So now we're able to provide the insights. It's able to be interactive for them. So if they're trying to think, okay, well, what is feeding this decision? They're able to go through, click boxes, and say, okay, well, what's the precipitation looking like? Is that what's driving some of these predictions? And then they can make a judgment call from there and decide to do something different or stay the course. We went this route because it's really about being able to scale and deliver and sustain the different things that we have in the pipeline. And what we've already deployed, some of the things we've deployed in the past aren't sustainable, but that's just learning opportunities that we've had as we've built things out. In this case, this graph is we're trying to help them operate effectively through icing. I know in Texas quite recently that they were hit unexpectedly and were unprepared for that. TransAlta, for a number of years now, we've had our own strategy in which we operate through our icing conditions to maximize our uptime. And in this case, it returns millions of dollars back to the business. And this is just one other key thing to help them make those decisions. All right, what's outstanding? What do we have left, at least in the short term, with the different things we have on the go? Governance, data governance, governance of our models. We've been working on this for starting last year. So none of that is, it's not net new, but we're just not quite there yet and getting it all documented out and accessible for people in the company. We know there's still work to do, and we have ideas of what our desired outcome is. We're just still trying to get to that state, a state where if someone wants to know what the power output model, where it is and how to access it, what's that API endpoint, they can go do it. So now we can all be talking in that common language. We understand the semantics of different words, because sometimes when I talk about availability, it might be different than what someone else is interpreting availability to be. And it can really helps facilitate that one source of truth. And as I was saying before, with the data lake, we're trying to load things in there slowly without just shoving a whole bunch of stuff. So we have that chance to govern it properly, and everyone knows where to go and how to access it and where to find things. In the middle there, there's Internet of Things. I frankly am not a huge fan of that, those words, but I think it conveys what we're trying to do. We need to be able to stream data from our sites in real time into our application. So that's one area where we've done trials the previous year, and they were successful. So now we just need to really deploy it out the rest of the way so we can get that across the rest of the fleet and to drive that control back down to the asset. So a lot of what I've talked about today, and I'm talking about things with the operators, or if I'm talking about stuff with the technicians, that's about making data-driven decisions. Well, now, what is the next step beyond that? It's about making data-driven actions. There's no reason why in certain cases where we shouldn't, a human would have already made that action on a turbine with that piece of information, why we shouldn't be also just go ahead and make that action directly. So that's something that we are still working on. We've had some success in some trials, but again, that is a very messy space. I know enough about controls to know that I know nothing about controls at the end of the day. And continuous integration, continuous deployment. We haven't really touched this yet. I think as we get to the point where we have more stuff deployed and we need to come back and rebuild or rerun things, that's when we're going to need to come in and really flesh out the rest of this automated pipeline that can do this stuff. So we're aware of it, but we're not there. A lot of our approach to things is iterative. As we encounter a certain problem that we want to work on, or now this thing has become a problem as a result of our work, that's when we'll address it. Obviously in some cases we are trying to get ahead of it, but it is the reality of trying to have that continuous delivery. Sometimes it doesn't make sense to stop everything until you know what you really need out of a process before you want to go in and bake everything in. Yeah, like I mentioned at the start with the power prediction, it's kind of the starting point for different things. It's not the be all end all. here's just a sample of the different things we've done as a result from our work with our power prediction. We do things with maintenance, whether we need to recommend wind vane alignments. So that's to ensure your turbines are pointed into the wind as best as they can. I mentioned stuff about icing mitigation and how we operate more effectively to minimize our ice. So I have a couple of screenshots, or I guess pictures here, I should say, of icing at one of our sites. That hole on the left is about 5 feet wide. I wish there was some other frame of reference, but I guess you can kind of look at the tree and try and imagine how large that is. And then we have a chunk of ice from that had fallen off the blades. You can kind of see there. So ice is a very serious thing. Like I said, it's been mentioned in the news with Texas. So I think it's on a lot of people's minds, but that's something that TransAlta has been dealing with for years now, where it's not new to us. We have some of the craziest icing sites in our fleet, but that just represents lots of opportunity. And some of the stuff on the trading, we do forecasting out power. So these are some of the business problems we're trying to solve with data. These are real machines with physical limits that adhere to the laws of physics. Do you understand how the different features of a wind turbine relate to each other and affect each other? And that's really where that domain expertise comes into play. So you can effectively solve the technical aspect of a problem. And then you need that human piece to make that organizational change. You need to have the empathy to understand what your customer is actually dealing with. When you're talking about icing, what is icing? It is that hunk of ice on your turbine blades that you're trying to mitigate that has real safety implications. You wouldn't want to hurt anybody. And yeah, it's just about taking risks. You need to be able to iterate on different solutions, and it's okay to fail as long as you're failing in the right way and you can keep moving forward. Be flexible with whatever it is that you have on the go. At TransAlta, we've come a long way in the past 18 months. That's how long our team has been around for. We've come a long way from, like myself, doing solo work to having an all-star team that's nimble and mighty. That's really how I would describe it, where we wouldn't be where we are today and do the crazy, awesome things that we are doing without them. And yeah, that's my presentation. So if anyone, we can go through the Q&A. If anyone has any questions for me after as well, my email is there. You can also reach out to me on LinkedIn. And yeah, do you just want me to go?